For problem 2, this is a cubic because the degree or largest exponent is 3, so that means it's going to have 3 solutions. Check for GCF first. I noticed they all have at least one x, so I'm going to factor out one x, and we're left with 3x squared plus 10x minus 25 equals 0. Now, there's nothing else I can factor out, but I noticed my leftovers are a quadratic. I'm going to try to factor this by split the middle first, and then if that doesn't work, then try a different method. Whenever I factor with the GCF, I'm going to see if split the middle works first. So I'm going to do 3 times negative, I'll write it over here, 3 times negative 25 equals negative 75. Write down your factors. I have 1 and 75. 2 doesn't work. 3 and 25. 4 doesn't work. 5 and drawing a blank, I think 15. 5 and 15, which works, right? If we make the 5 negative and the 15 positive, we get positive 10 in the middle. So I can factor this by split the middle. So whenever I take out a GCF, I like to bring it all the way down. And I know when I factor by split the middle, my answer is going to look like that. So I know my new middle. I'm going to try to move this over. I have some space here. All right. I'm going to rewrite my middle to be 3x squared minus 5x plus 15x minus 25. We have 4 terms, so I can factor by groupings. My GCF between the first group is x, and we're left with 3x minus 5. Bring down the plus sign. My GCF between 15 and 25 is 5. Whatever the first parenthesis is, that's what the back parenthesis needs to be. And then when we write our final parentheses, the GCFs go in one, and the repeating parenthesis, you just write it once in the other. Check and see, we can't factor our parentheses anymore. We are done factoring. Now we can solve. We're going to take each factor and set it equal to 0. X equals 0, x plus 5 equals 0, and 3x minus 5 equals 0. Here, there's nothing to solve for, so there's one of my roots. Move the 5 over, so x is equal to negative 5. Here, when I solve, move the 5 over, divide by 3, so x is equal to 5/3. And there we go. There's problem 2.